Okay, this is part 3 of lesson 13. We're talking about fractions. So we are going to be adding and subtracting fractions with like denominators, meaning the same bottom numbers. So we first of all need to understand that we need a common denominator. So we're going to highlight or circle common denominator. All that means is the bottom must be the same. Please write this down. Okay, so the bottoms of your fractions must be the same. Okay, so it says to add proper or improper, the bottom numbers need to be the same. Okay, so we're going to take a look at these examples. So each of these have a number on top, a number on the bottom. The bottom numbers, as we notice, are identical. They have to be. And what happens? All we do is we keep the bottom the same number and we add the top numbers. That's all we're doing. So if we take a look at these, we're taking 2 and 3 and we're adding them and we're getting a 5. So what they've done is they've taken a picture with a rectangle and they've shaded squares in the rectangle. So you can make your rectangle equal to the same amount of squares. So if my bottom was an 8, I'd make 8s. If my bottom was a 10, I'd make rows of 5s or rows of 2s. All different ways you can make your diagrams. So now over here, if we look at B, we see that 6 of them are shaded out of 21 possible. On the next one, we have 11 shaded out of 21 possible. We are going to be adding them to get my favorite number 17 on top. So does it matter which order you shade them in? No, it doesn't. It just matters that the bottom number stays the same. So if you take a look at the objects, if we didn't look at numbers, let's get rid of the numbers. If we look at the objects, they've divided each rectangle into the same amount of squares. That means the bottom numbers are the same. So every diagram is going to have the same amount of squares. That's what matters. Now, what do we do if it's mixed numbers? Well, we just make pictures that are whole numbers. So we still divide it into the bottom. So whatever the bottom of your fraction is, if it's a 6, we make boxes that are a rectangle with 6 parts. If it's 9, we make rectangles with 9 parts. So these ones have 6. Here we have the number 2. Well, the number 2 means I have 2 that have the whole numbers completely in there. Didn't show up, so I couldn't send them. And so we have 2 holes. That's our holes. Everything is shaded in the whole number ones. Okay. Then we've got, again, another hole. Now, if we take a look at all of the whole numbers, just look at the pictures. All we've got is we've got 3 of them shaded. There's our 3 holes right there. Though that's our big number. Okay. Now, what we look at then is we combine them on the ones that are left over. So we see we have 2 left over here, 1 left over here. We're going to draw them all together here. We have 3 left over. Okay, so that's what we're doing when we're looking at our squares. Okay, turn to page 14, please. Now they're showing how can we do it if we do it straight up and down. What if we put the numbers vertically? And this means put the numbers straight up and down. So we just discussed that the 2 plus the 1 on top of our fractions, we add them, and that shows us how much are left over. That's the same thing as we did in the diagram before. It's the same question. This time we're just doing it vertically. So there's multiple ways you can add fractions. So what you're doing is you're doing it the way that you find the easiest, but you still have to be able to do it both ways. Okay, you have to be able to do it both ways. All right, let's look at the next one. What did they do to the 3 and the 6? Take a look. My answer doesn't have a 3 and a 6 in it. It's got a 1 over 2. Why does it have a 1 over 2? What did they do to the 3 over 6?
7.
What did they do to that 3 over 6? I just highlighted the word. They reduced it. So when we reduce fractions, like we discussed yesterday, we either divide them or we times them by the same number. If we're making the number smaller, we're always dividing. If we're making the number bigger, we times. This is to make the number bigger. Number gets bigger. Whereas if you divide, your number gets smaller. Okay, and when we reduce, reducing means your number's going to get smaller. We want it to reduce smaller. So what we do is we see what numbers do 3 and 6 divide by. So I would take 3, make a factor chart. 1 times 3, that's it. 6, make a factor chart. 1 and 6, 2 and 3. Which number do they both have the same in the chart?
6.
Everybody has a number 1 the same. You'll always find the number 1. But what other number do they have the same?
2. 6.
Look in the factor chart.
4.
Right here. What numbers do they have the same?
3.
Yes, the 3. So the 3 is the same. So what you're going to do is you're going to now divide by the same number that you found, which is the 3. So if we divided 3 by 3, so 3 divide 3 gives us our 1. 6 divide 3 gives us our 2. And that's how we get our reduced fraction in our answer. Okay? There. Now we're going to subtract the fractions. Every rule is the same. The only difference is our top numbers, instead of adding them, we now subtract them. So now they took the 4 and the 3, subtracted to get our 1. You're just showing that what you're doing is you're removing. So what you would do is you would cross those off. So what you can do is draw the diagram. You only have to draw one of them, and then you cross off how many is on the next fraction. So this one shows me I have 4 shaded. I need to remove 3. So I would cross off, I could go 1, 2, cross off 3. Does it matter the order you cross them off in? No. And then you can circle your leftovers. The leftovers will be your top number. Okay, so after you cross off and remove what it asks you to remove, then you have your leftovers. Let's look at B on the top of page 15. It's doing the same thing. It shows you one diagram. 15 of them are shaded. You're removing 11 of them. So I could say, okay, there's 4, there's 8, there's 9, 10, 11. I have 4 left over. Now we need to reduce that fraction. So I'm going to make a factor chart of 4 and 20. But what's easier? If I want to reduce, I look and check if the numbers are even or odd. Who remembers how to tell if a number is even or odd? Do you remember?
The thing that you do 1 and then 2.
You're thinking factor chart. All I want to know is, what did I just ask you? It's on the video and I can't remember what I just asked. Oh, the reduce it.
Yeah.
How do you find what you divide by to reduce? So how do I know if it's even or odd numbers? What we're going to do is we're going to... Yes. So hang on. You're looking at the digits. If it's a 2-digit number, you're looking at the last number on the right. If they are even numbers, they will always divide by 2. So we need to reduce our fractions, folks. So we're going to divide both numbers by 2, and that's going to give us a 2 over 10. Now we're going to reduce that again because they're both even. So we're going to divide by 2 again, top and bottom, and we're going to get 1 over 5 left over. Okay, so that's how many we get left over out of 5. So always remember, we have to reduce our final answers if it's a fraction. Now, what do we do if it's a mixed number? If the bottom numbers are the same, it's okay. We just subtract the big numbers and then deal with the fraction part. The easier way is to turn them to improper. Do you have to? Not always. If they've got the same bottom number, you don't have to go to improper. If they have different numbers, we'll deal with that in a minute. So these numbers are all same number on the bottom. So how do I know what to draw for my rectangle? How do I know how many squares to divide a rectangle in? It'll always be in the same amount of squares as the number on the bottom. So I know now I need a rectangle divided into 6. And then it shows me I have 2 full ones. So that means these guys are completely shaded. That's my 2 holes right there. Okay, over here I've got 1 whole. And now what I'm doing is I'm removing one of these, and I'm removing one of these baby squares. So how much is left over? Well, they're showing me one of these is left over, that's this guy, and 3 of these are left over, just like it shows here. So you're trying to remove the objects that it tells you. And then we have to reduce our fraction. This is not reduced. So our whole number is big, but what happens when I have an odd number and an even number? Do you remember? Am I always going to divide by 2?
No.
No. If I have odd and even,
5.
I need to divide starting with 3. So that means I'm going to divide 3 by 3, and I'm going to divide 6 by 3, and that's going to reduce my fraction to 1 over 2. So your final answer, always reduce. Write this down. Reduce your fraction. Your whole number will stay the same. You're just reducing the fraction.
So it's 5. Like divide by 5. That's what you.
If a number ends in a 5, you divide by 5. That's when you divide by 5. If it's odd, you start dividing by 3s. That's okay. All right, now we're going to look at the next object. The next object is divided into parts of 2 because that's the bottom number of the fraction. So now this shows me I have 2 wholes and I need to remove only half. So I'm removing this. That's all I'm removing. What's left over? My 2 wholes. That's what's left over, and that's what it's showing me. So if you've got objects, draw the objects. It's easier. So if I've got an example like this, and I say I've got 3 and 1/5, well, let's go 4/5, minusing 1 and 1/5, you're going to divide an object into 5s. So I would have a long, skinny rectangle, and I would divide it into 5 pieces. And then I would shade 4 of them. So I need 1 shaded, 2 shaded, 3 shaded, 4 shaded. That guy needs 4 of them. Then it says I need to remove 1 of them. If I remove 1 of those, and then I've got these guys, I have 3 whole ones. 3 holes. How many holes do I have to remove?
3.
What's my big number, the second one?
1.
It's a 1. So that means I need to remove 1 of those. So how much is left over? 2 big ones. And how much is left over here? 3 out of 5. Okay, so when they show you pictures, okay, or if they just show you numbers, you can draw the long rectangles. Okay, and that might be easier for you. Now, this is a special case of subtracting. This means subtracting from 1. The digit 1, you can create the digit 1 by putting any number on top of itself. So I could go 99 divide 99. That equals 1. Whenever you've got a number on top of the same number, it will always divide to give you a 1. So when you've got a fraction, here's an example. When you say you've got a fraction that says, let's say I need, I don't know. Let's go with 1 minus 2/3. Well, my 1, I have to convert. I'm going to convert to a fraction. Now, a whole number is going to convert to the fraction with the same bottom number as the new fraction. So if you look at the next number, it's a fraction in the question. That's the bottom number I'm going to convert my 1 to. So what's that number going to look like? What is that?
1.
What's the 1 going to change to?
A 2.
I'm going to put a number on top of itself. I want the same number as the bottom here. So what number should I use?
3.
3. So I'm going to have 3 over 3. That's what this number becomes. And I'm choosing the number 3 because that guy's a 3. Okay, that's why I'm choosing the number 3, because 3 is the bottom of my next number. Now I write the next number. Subtract 2 over 3. Now when the bottoms are the same, you just deal with the tops. So that would mean if I had rectangles, I have 2 rectangles. One is completely shaded with 3 parts. And then it says remove 2 of those. Well, if I get rid of 2 of those, how much is left over? One of them. And that's our answer. So our answer would be 1/3 is left over. So there's our leftovers. Yeah, there's about 5 different ways to do it. And what?
Could have just minus the 1 to the 2.
Well, what's 1 subtract 2? That's -1. So it doesn't work that way. That's why we have to convert the big number to a fraction. It has to have that same bottom number so we can subtract the tops. Okay? So let's take a look at this next question. This next question here, we've got 2 minus 1/6. What they've done is they've created a fraction and they've borrowed a 1. They've borrowed the number 1 from one of those digits. If I subtract 1 from the number 2, what do I get? What is 2 subtract 1?
3. 1.
2, and I got to get rid of 1.
-2. 1.
2, get rid of 1. 1. So I'm going to have 1 left over. What should my fraction look like now? What is the bottom number on the fraction that sits next to that number? What's the bottom number? I highlighted it in yellow. What is the bottom number? It's a 6. So that means I need to put a 6/6 now. These two together, that says 1 plus 1. That's going to give me 2. So this number right here, I made into this. That's what it became. Now I'm going to subtract 1/6. So if I were to draw my rectangle, this is what I've got. Well, actually, I only need 2 of them. So I've got a full 1, and then I've got 6 here shaded. Now it says remove 1. This says remove 1. So if I remove 1 of those right there, how much is left over out of 6 that's shaded? If I remove 1, how many are still left? 5. Good. So that means, and I still have this big number 1. I still have the 1 and 5 left over out of 6. So that's how they get the leftovers. Okay, last little bit we're going to talk about with subtracting. So what if the top number is bigger? That's okay. Sometimes we have to do that. So look at this one. The number 1, can I take away 3 from 1? Look up on the board, please. Can I take away 3 from a number 1? No, ma'am, I cannot. I need to take one of these. I need to borrow, so I'm going to subtract 1. I get my 2. So if I subtract 1, I'm taking 6 out of 6 parts away. So I'm taking 1 plus 6 parts. That's how I get my new number 7 on the board. Okay, pushing play. Here we go. So when I borrow a whole number, I'm borrowing the same amount of parts as the bottom. So when I borrow a number, the bottom number has 6 parts. So that means I'm adding 6 parts to my top number that has a 1. 1 part and 6 parts makes 7 parts. That's how I get my number 7 at the top. Okay, when I borrowed 1, now that means my top number is going to be bigger. Okay, now my top number is big enough to be able to subtract 3 of them. So now I can subtract 3 and I get 4 left over. My last step is to make sure I reduce. Okay, I need to reduce my fraction. So 4/6, we are both going to divide by 2 because they're even numbers. And that's going to reduce them and make them smaller. So that's going to become 2/3. And that's where we get our final answer. Okay, so we have 2 whole parts and then 2 out of 3 reduced remaining. All right, we're doing the exact same thing. The next question, I have a 2 trying to subtract a 4. That's not going to work. So I'm going to borrow 7 from the 8. So that means I'm subtracting 1. I get my 7, but I'm adding 7 to my 2. What happens when I add 7 to my 2? I'm going to get 9. Now my top number is big enough to be able to subtract that other number. So now I'm going to get 9 subtracting 4 is 5 left over. Okay, because you always need to have that number big enough to be able to subtract it. Okay, now we're going to subtract a whole number from a mixed number. If I want to subtract a whole number from a mixed number, all I'm literally doing is looking at the big numbers. I don't need to look at the fraction. I literally look at the big numbers, and that's all I'm subtracting. Just the big numbers, yep. Now if we look at, what if the bottoms are different? So top of page 18, what if your bottoms are different? We have to make them the same. But in your calculators, they will do it for you. So as long as you're able to type it in your calculator, it will solve it for you. You have to be able to type it in proper. So fractions need brackets. Okay, they need brackets in the calculator. Brackets in calculator. So everybody needs a calculator with them, and I want you to practice this with me, please. So we are going to take bracket 5, divide 10, bracket plus.
It's really foggy to me. Looks like my Nokia 4.
So the second number, we open our bracket and we're going to go 13, divide 15, close our bracket, equals. Then you're going to hit the button that says second PRB. You're going to hit second PRB and then equals again. And that's going to give you your fraction in lowest terms. And it'll change it to a mixed number as well. So you got to go second PRB. So I want everybody to go to the fraction on the top of the next page. Everybody grab these fractions. Top of the next page. So we can find the same bottom numbers. But since we have calculators, we don't need to worry about converting to the same bottom numbers. Our calculators will do the function for us. So, but what we have to do is put it to improper. So we're going to change mixed, and this is on your quiz this afternoon, to improper fractions. So this is where we loop, times, and add. So we're going to loop it, times it, then add it. That becomes my new top number. So that's going to give me my favorite number on top, 17. My bottom stays the same. So my first number I've converted. Now I say plus, and now I convert my second number. I loop it, I times, and add. So we're going to get 22 on top of 7. Now I can go back to my calculator, and I can put brackets around each and hit equals, and then hit my second PRB, and it will solve it. Okay, so as long as you know how to use the calculator, it will solve it for you. So you're going to go bracket 17, divide 6, bracket, plus, bracket, 22, divide 7, bracket, equals. Then your second button, PRB button. Okay, probability, and then the equals again. Okay, so that's how you're going to solve your fraction. And that's going to give us, let's see what my answer is here. Plus, that's going to give me 251 over 42. That's what your final answer should be. And then if you want to convert it to a mixed number, you can. Now, if you check the decimal number is going to match this decimal number. So if I go 41 divide 42, let's get our decimal. 41 divides 42. we're going to get 0.96. So this is 5.976, and it's run on forever. If I do the other one and I divide them, you're going to get the exact same number, 5.976, etc. So convert it to decimals to make sure that the decimals match. That means you did the question right. Okay? If your decimals match, you did the question correctly. Okay, what if there's 3 fractions? If there's 3 fractions, you still have to do all of them, but convert the mixed to improper. So the first step is always to convert mixed to improper. And that's first. Okay, so that's the first thing you're going to do because all of them have to be in fraction form, no mixed numbers. So you need improper fractions if you have a mixed number. So that means this one right here, 1/4, he's going to change. So we're going to get loop it, times it, add it. So we're going to get 5/4 plus 2/3 plus 3/4. So you do the same thing in your calculator. You will put brackets around the numbers. The fraction bar is the divide sign. You will do it all in a row in your calculator using brackets, hit equals, and hit your second PRB. It'll give you your final answer reduced. Okay, and then your second PRB and equals. Okay. And that concludes adding and subtracting fractions.